Welcome. Welcome to the presentation. I'm here to discuss how modeling a player's limited amounts of anaerobic energy can impact their ability to play on the ice. With a full tank, with their anaerobic energy at full, they are competitive and explosive, but without it, they can become sluggish and slow. To provide some background information, this is based on the W prime model, and its premise is that it can estimate how much anaerobic energy is used or replenished at any given point in time. Unfortunately, this requires a lot of lab-based testing and is impractical based on the data that we have that's coming in. So instead of using the W prime model, we can use the D prime model. And all we need is positional tracking data, and specifically player velocities. And from this data, we can calculate or model their critical speed, which is the speed at which players use and replenish their anaerobic energy at the same rate, to then derive their D prime values, which is the maximum distance that they can travel at maximal efforts above critical speed. So to put things more simply, we can look at the graph on the bottom right. And we see that whenever the player is traveling at speeds above their critical speed, their D prime value, their anaerobic energy stores, decrease. And the opposite is also true, that when they're traveling at speeds below their critical speed, their anaerobic energy levels increase or replenish. There were two proof of concepts that I did, one in collegiate soccer and one in junior hockey. In collegiate soccer, we found that critical speed values were underestimated by about 15% when compared to lab-based tests, and their D prime values were somewhere between 120 and 180 meters. This value is intuitively probable, and we see that the critical speed values, their underestimation is in keeping with the current research that's out there on critical speed testing in the field, essentially. In junior hockey, we found that their critical speed values were nearly the same as in collegiate soccer, but the D prime value was almost double. There's no true explanation, but my best guess is that the extra distance gained is because of the amount of glide, or the distance they glide between strides. Unfortunately, there's no research on the topic, and there's no way of validating these findings. So moving forward, what I wanted to do was apply this knowledge. And what I've been doing is creating a dashboard that coaches can use to visualize player energy levels while they review game tape. This can provide insight to not only the coaches, but sports scientists and performance staff to understand how players respond to different tactics, how they respond to the pace of play, and can potentially indicate where their strengths and weaknesses are. Now, moving forward, we have to understand that this is a work in progress, and there's no definitive answer here as to, is this going to absolutely be 100% of the time? But I do believe that if we keep going down this path, by using the D prime value or the D prime model, that it has a true potential to influence how the game is played in the coming years. Thank you. This is a recording of the presentation, and feel free to reach out on Twitter and email. Those are the two easiest ones. And I appreciate you taking the time out of your day to watch this presentation.